Hello, welcome back to Organic Chemistry. My name is Todd Rothman. In this chapter, or actually in this video, we're going to cover functional groups. We're going to start to learn what they are and what important characteristics we should identify before we really get into the heart of organic chemistry. Okay, so functional groups is at the foundation of everything. All things that happen for a molecule occur because of the characteristics or properties of its functional groups. So you might have a very large molecule or a small molecule, but they'll have these certain areas, regions, that will be considered its functional component of the molecule. And that's what dictates a lot of its properties and reactivity and so on. So let's get started. Now, as you can see, there's only 3 sections and then problem solving, and that's because this isn't a very challenging topic, but it's just something essential that we go through and that you kind of start organizing your mind for the rest of the semester. All right, so as I said, number one, what is a functional group? And so we know that they could be small or large. That really doesn't matter. It could be a few atoms or thousands of atoms. But usually, most of a molecule that's very large has a lot of hydrocarbon component to it. But then there's some areas, maybe one or a few, that have some other component that would define it as far as its reactivity, its properties, as I had mentioned. So, as I wrote here, regardless of the size, there is usually a specific area of the molecule that defines the many properties of the molecule and reactivity. So now that area is called a functional part of the molecule, and the specific type is known as a functional group. Now, as I wrote here, luckily there are a lot of functional groups. I mean, you can have several dozen, but we don't have to know every one. We just have to learn 20, maybe 15, somewhere around there. So we don't have to learn every single functional group. But what we'll see is that functional groups is a way to organize reactions because let's say, for example, you're learning about alcohols. They all, no matter what the alcohol is, they have very similar reactivity. So instead of having to learn about millions of molecules that might have alcohol groups on them, we could learn a general idea of what alcohols do, and most molecules will fit that bill. So it's kind of interesting how we could organize, based on functional group, thousands and thousands and maybe millions of molecules that would react very similar as each other. Okay, so like I said, luckily there's only a few that we have to do here, about 20, 15 to 20. So here's an example. Now, in this case here, I circled the functional groups. And as you can see, there's some hydrocarbon that's not circled. So if I highlight it, this is like a bunch of carbons here, and there's 2 carbons there. There's 4 carbons here. Those are just the backbone. That's the foundation of the molecule, just the skeletal structure. But notice that we have these unique things here, like a nitrogen or an alkene, this is called. And this right here is a group we'll learn about called an ester. And this is also a nitrogen called an amine. Now, these are the functional regions of the molecule, and that's where its properties are dictated from, its reactivity, how it engages and interacts with other molecules is all based on that right there. Okay, so the hydrocarbon is kind of, that's why we start by learning about hydrocarbon in this chapter, but it's like the foundational piece. It's what we build on to build up our molecule. So here is one thing I want to point out before we look at the actual functional groups, and that is some of these abbreviations that your book expects that you would know, and the class that you might see these abbreviations come up. But so let's just get that a little bit organized in one place. So the first thing is R. Whenever you see a letter R, capital letter R, that means we're dealing with carbon. Now, the idea here is that sometimes you don't really want to draw out the entire molecule. Like, I'll give you an example. Let's say I really care about this blue carbon that I'm highlighting. Now, if I have to write this out, draw the structure 30 times, it's going to be really annoying. Even 5 times even twice is annoying, right? This is a big structure. So, if all I really care about is that blue carbon, then a way I can identify is I could say this blue carbon is attached directly to 3 things, and they're R groups. So notice how I'm really simplifying this molecule, but sometimes you don't want to do it this level of simplification because you might really need to know more about the other side of it. But imagine if all I really care about is that blue carbon, and I'm not so concerned about anything else. So I just covered this big structure by writing 3 R's around that blue carbon. And now that's what we do in order to simplify our lives when we're writing things on paper. And so this is what the idea of R is. It's a way to just kind of get rid of all the complexity that you don't need to focus in on. Okay, so a lot of times, like for example, the nitrogen, let me just make sure this is clear. This nitrogen here, if I write NH, how many carbons are touching it? 2. So I could write R twice, R and R. And now I'm ignoring the complexity of the rest of the system and I'm focusing in on that nitrogen. So you see how we could work that? That's the use of R. That's why we use R. Now halogen's very similar. If you don't care whether it's bromine, chlorine, fluorine, iodine, if it doesn't matter which halogen, then you'll see the letter X. Capital X tells us that we're dealing with a halogen, but we don't care what halogen, okay? pH is a way to refer to benzene, which benzene we'll learn about right now in the next section, is a 6-membered ring that has a whole bunch of alternating double bonds. Now, this is again something that we tend to not always want to write out, especially if we don't really care about the benzene. It's just part of the molecule that's not important in our focus. Well, then we'll write pH. So pH represents benzene. Now, this letter N is really what I want you to see here, but the most common is NBU. N means normal. Now, normal is just a straight chain. So let's say, for example, I have 4 carbons like this, and then there's something here. I'll call it Z. Now, if I have another connection like that, these are not the same structure. So there are 4 carbons in a straight line, but the question is, where is Z connecting in to those 4 carbons? And in the top case, it's at the end, whereas in the bottom case, it's in the middle somewhere. So whenever it's a straight line and whatever is attached to it is on the end of that straight line, we could just say N for that. This means N. So NBU means normal butyl. Now I know I'm jumping ahead a little bit, but I know in Gen Chem you learned about methane, ethane, propane, butane, and so on. So butyl is 4 carbons. And so if you have 4 carbon straight chain and then something's connected at the end of it, you might see NUBU. Okay, so I'm sorry, NBU. So that's just a very popular thing that you might see in your textbook or in some other places. All right, now you wouldn't necessarily write this. Let me make that clear. The NBU is something more for if you happen to see it, you'll understand what it is. Not so much that you'll ever write that. Okay, R you might use, X you might use, even pH, but NBU is more of just if you see it, you know what they mean. And again, it goes beyond the scope of just butyl. It could be well, not methyl, but N-propyl or PROP or something. So N is just straight chain. On the end, something's attached to it. Now, this I already covered in the previous video. I just want to make sure it's clear here. When you look at a carbon of reference or of interest to you, if you count the number of carbons that touch it, which I'm writing R now that we know R represents carbon, well, if you count the number of carbons that are touching it, it tells you the degree of that carbon. So this carbon is quaternary. It's a 4th degree carbon, quaternary carbon, because it has 4 R's attached to it, 4 carbons touching it. And of course, this is tertiary, secondary, and primary. Now, remember that the hydrogens also have the same degree. So if carbon is quaternary, well, if carbon is tertiary, then the hydrogen on it is also considered tertiary. So we could say that these are tertiary carbon or tertiary hydrogen, depending upon how we want to reference it. Okay, so this is a review. Again, I know I did that in the previous video. Now we're ready to go over functional groups. Now there's a whole bunch that we have to know right now, but you really just have to get a general idea of what they look like. Okay, that's the most important thing. And so I just kind of gave you a summary chart that you could just work from to master that. Now the first one is actually not a functional group. Alkane is not a functional group, but I just want to organize all of our things that we need to know on this chart. But this one here in particular is not a functional group. It's just the skeleton of a molecule. Okay, now an alkane we know from the previous video is just